Good morning, everyone. Can you hear me?
Yes.
Okay. Well, I'd like to welcome you in the second day of the International Balkan Conference of Challenges in Civil Engineering. I am Rania Musafarai, and I'll be the moderator of session 3. So without losing time, I would like to invite Ms. Ilda Tole and Andrei Zviertsan for the paper Supplementary Cementitious Material and Mechanical Chemistry for Sustainable Concrete Production. Ilda, you're...
Yes, hello. Good morning. Can you hear me?
Yes.
Okay, perfect. Then I will share the screen. Okay, so I hope it's okay, it's visible. So good morning to everyone. It's a great pleasure to be here. It's a great pleasure actually to present in my home country. And it would have been really interesting to be in person, but yeah, due to this COVID, actually it's a very interesting conference even in this digital form. So thank you very much, first of all. My name is Ilda Tole. I am a PhD student at the Luleå University of Technology in Sweden, and under the supervision of Professor Andrei Zviertsan. And today I will present my studies regarding supplementary cementitious materials and mechanochemistry. So starting from the first issue that all world is facing is reducing the CO2 emissions. And also the European Cement Association aims to reduce by 30% the CO2 emission for cement production, and by 2050 to achieve a zero net emission. So building carbon neutrality in Europe, it's a goal to achieve and something to take in mind also in cement industry. There are different routes for the reducement of the CO2 emissions as the thermal efficiency, the fuel substitution, and the carbon capture. And some of them has achieved the maximum efficiency that it can be. And one rapid countermeasure is the substitution of clinker with supplementary cementitious materials. And this study wants exactly to be placed in this context, trying to answer to some of the trying to answer to some of the sustainable development goals from the 2020 UN's agenda. So climate action, innovation, responsible consumption and production of resources, and building of sustainable cities. In this study, we are utilizing two different materials or two different sources, and it's mainly clay as a low-grade supplementary cementitious material and the air-cooled blast furnace slag. If we have a look on the overall presence of these supplementary cementitious materials, that we can see that actually there are different sources, and some of them has a main challenge to be available as resources. As for example, the main challenge is the location of these blast furnace slags, for example, or the decarbonization of the power structure, which is reducing the amounts of fly ash materials. And from the other hand, there are a lot of sources that are commonly occurring and can be found everywhere and are not yet utilized, as for example, clay in these cases. We can see the high amount of unused residues here as 600 million tons per year, for example, and the great amount of the primary source supplementary cementitious materials which can be utilized. So starting with clays, I start from the actual area when I'm living and studying. So in Sweden, the presence of clay, it's not really so much. So, and it's mainly based in this south area. And the main problem in this case is the instability of this material. So often, previous to construction, all this unstable clay soil has to be removed. And usually it is deposited next to the construction sites or maybe in some area in the neighborhood, generating huge deposits of this waste clay. So exactly in this context, the idea is to utilize these clays to activate those and to then further produce concrete to build. But if we have a look in a wider scale, so if you have a look in the world distribution of the clay percentage, that we can see that this material is present in almost all the areas. This map is outsourced by LandGIC, and the percentage or the clay content in percentage is showed with the yellow where it is the less and with the purple when it's highest. So we can see that all Europe and the Balkan areas have a high content of clay in their soils. So actually these sources can be utilized for further development of sustainable concrete. And having a look instead on the other material utilized in this study, so the air-cooled blast furnace slag. Well, this material is coming from as a byproduct from the metallurgical process, and usually it is water quenched. And quenching with water is producing the well-known ground granulated blast furnace slags, which is already utilized in laboratory and industrial scale for partial or full replacement of Portland cement. While there is actually a lot of effort to not utilize anymore this kind of quenching because the water cooling is causing a lot of pollution. So in some areas, the air cooling is utilized. So it means that all these molten materials coming out from the metallurgical process is just let to dry in air. And this is actually a photo taken here near the metallurgical industry in Luleå. So there are mountains of this material deposits here, at least here in this place when I'm living. The difference between these two materials is the reactivity, because as I mentioned before, the ground granulated blast furnace slag is already proven to be used for the replacement of cement, and it's an amorphous material due to the rapid quenching with water, while the air-cooled blast furnace slag method produces it's a crystalline material. So actually it's really poorly reactive and is mainly utilized as coarse aggregate for road bases. So again, sources that are unused and just deposits in some not lived area. Clay itself, but also air-cooled blast furnace slag, are thermally treated usually, and clay, for instance, is well known that the calcination or the thermal treatment can produce a material that is good for being a replacement of cement. But again, the thermal treatment is putting a lot of more CO2 emissions because the temperatures to be utilized are quite high. So the proposal was to utilize another clean technology that is not using high temperature and not using additional chemicals, and in this case is the mechanochemistry. So from the word itself, mechanochemistry is the chemical reaction that is induced by mechanical energy, and it can be connected to antiquity, so to the frictional forces between stones, and then the chemical reaction with the oxygen in the air, and then the procuring of fire. And however, in history, they are talking about proof on documents of mechanical chemistry back to 371 before Christ, when grinding in a mortar with mortar and pestle, the cinnabar can be produced on quicksilver. The first proof on document of mechanochemistry as a branch of chemistry was of 1891 by Ostwald. However, nowadays, in the last years, this kind of technology is largely used for producing different materials. In our case, the mechanochemical activation is done in a planetary ball mill, and as from its name, so it has a kind of a planetary movement. So the jar with the ball and the material that is processing it is rotating around its axis and around the main axis of the equipment. And going to the laboratory view of this machine, of this equipment, so this is the one that we are utilizing. Different parameters can be changed to achieve different type of activation. Actually, another study was done on the optimization of these parameters, and in this study case that I'm presenting, I'm just utilizing the optimized process parameters that I have found previously. So in this case, a fixed rotation speed at 500 rotation per minute, ball to powder ratio of 25, and grinding duration of just 20 minutes. So both clay and air-cooled blast furnace slag were treated with this process. And not only the particle size distribution was evaluated, but the main indices to evaluate if we are having some amorphization of the crystalline structure, that for us is the main indicator of reactivity of the material, was doing some X-ray diffraction analysis. And as you can see, for the clay, all the peaks with the phases that were found in this not treated material were completely then disappearing after treatment. That is a sign of amorphization of the structure. The same thing was happening for the air-cooled blast furnace slag. So we are having really amorphized material after treatment in the grinding machine. Then the solidification was done on two different methods. So we are doing the first with the cement replacement of clay, and the second the alkali activation. And with different standards, we evaluated the solidification rate. So 20% of clay in this case was substituted with the cement, and comparison of the compressive strength were done to evaluate if clay was pozzolanic or not. And in the other method of solidification, air-cooled blast furnace slag was utilized alkali activated material. And for the cement replacement, for the first method, so the comparison among the strength activity index, we were having absolutely good result with the treated clay going over 127%, where the minimum required was 75. However, this was not enough. For that, we choose to do the Fratini test or the chemical analysis, because we already know that after grinding, the material was fine, so a filler effect can contribute to the increase of the strength values. While another comparison was done with the alkali activated material, and we were having a nice comparable result of the compressive strength with more utilized ground granulated blast furnace slag. So, and here you can see actually from the picture how these alkali activated materials looks. So this is the alkali activated material with a not treated air-cooled blast furnace slag. So it was not even possible to remove this material from the molds. While after mechanical activation, we had some samples that were comparable with ground granulated blast furnace slag. While the test method or the chemical analysis, direct chemical analysis of the reactivity of clay was done with the Fratini test. And as from the Fratini test, all the results lying above the curve of the solubility means that there is no pozzolanic activity, while all the results below means that there is pozzolanic activity, and the treated clay was lying just here above. So, as the conclusions, we could really state that mechanical activation in a ball mill is an environmentally friendly process, which is enabled to increase the chemical reactivity and the pozzolanic activity of clay, and can increase also the reactivity of poorly and reactive crystalline air-cooled blast furnace slag. Normally, it is necessary to optimize the process parameters, and especially for the air-cooled blast furnace slag. So thank you very much, and I'm here to welcoming any question from you.
Thank you, Ms. Tolia. If the audience has any question, you could. We have time for 1 or 2 questions. It was a very interesting presentation and interesting topic, especially nowadays.
Thank you very much.
As I see, there are no questions, so I think we can start. We can continue with the second presentation. From Mr. Mohammed Magan Ali and Musa Adam, study of microstructure of waste tire ash concrete using the scanning electron microscopy and X-ray diffraction techniques. So you have 15 minutes. The stage is yours, Dr. Adam.
Okay.
Yes. Yes, it's okay.
All right. Okay. I would like to say good morning to all. My name is Dr. Musa Adamu from Bayero University, Kano, Nigeria. And currently I'm a I'm a lecturer in Bayero University, Kano, Nigeria. And currently I'm a postdoc student, researcher, at Chulalongkorn University in Bangkok, Thailand. So I'm here to present my our research title study of mechanical microstructure of waste tire ash using SEM and XRD method. So first I'll go to the introduction. So we say that the study of concrete microstructure has benefited greatly from the use of microscopic examination, in the particular the scanning electron microscope. So SEM and XRD and microanalysis techniques have been developed and used for imaging the complex microstructure of concrete, providing images of sub-microstructure definition. So according to Stossman 21, the application of SEM has enhanced the possibility of characterizing cement and concrete microstructure and subsequently aid in the influence of supplementary cementitious materials, concrete durability problems, and in prediction of service life. So microstructure imaging has been adopted as an essential tool in the study of materials related to construction sectors such as concrete, cement, paste, soil, rocks, etc. SEM, which is a modern generation concept of microstructure imaging, has been described as a versatile analytical workstation capable of providing several different types of image, quantitative data relative to porosity and cement paste composition, and information about microstructure of concrete. So then we go to the waste tire. The performance of the waste tire ash as pozzolana for partial replacement of cement in concrete, if possible, and found to conform with the given standards, will go a long way in providing a huge environment of disposition, disposing the ever-increasing scrap tire nuisance in our environment, and at the same time make our concrete more indigenous with less cost of production. According to Peter and John, 2010, well over 95% of cement used in concrete throughout the world is Portland cement and in its various forms. So any effort aimed to reduce the Portland cement content in concrete will certainly be of interest. A hydrous Portland cement cannot bind sand and stone, so it requires the adhesive properties only when mixed with water. This is because the chemical reaction of cement with water, referred to as the hydration of cement, yields product that's possess certain and hardening characteristics. So this paper attempts to show how the combination of SEM and XRD procedure can be used effectively in explaining the microstructure of pozzolana cement, concrete during the hydration process, which with WTA as pozzolana. Conventionally, the SEM and NDS provide an easier, more readily applied procedure. So the materials used here are Portland cement, ordinary Portland cement obtained from Nigeria with a specific gravity of 3.15, with a sharp sand from Kano, Nigeria with a specific gravity of 2.8 and classified zone 1. Then crushed granite of 20 maximum nominal size and 2.85, bulk density of 1,500 and impact value of 20%. Then we use the waste tire ash as supplementary cementitious materials, and it was obtained by burning the waste tire at controlled temperature of 500 degrees and allowed to cool and sieve through a 75 micron sieve. So the method we adopted is here we use the concrete used for this study was obtained using the absolute volume method based on the 1:4 mix ratio, using trial mixes initially, concrete with compressive strength of 29 Newton per millimeter squared at 28 days curing with W water cement ratio of 0.65 and slump range 500 mm was adopted. Then the slightly high water cement of 0.65 was intentionally adopted because it is known that usually most mineral pozzolanic materials are known to be high water absorbers. So the form volume method is this, where W is cement, water, C is cementitious material. And so using the formula, 7 mixes shown in table 1 for the batch quantities of concrete materials and WTA were obtained. So this is our table. We have our waste tire ash, the cement. Then we have the sand, the crushed granite, water, and the water cementitious material ratio. So the WTA, okay, this is how we obtain it. Was obtained by burning sliced pieces of waste tire to ash through heating at temperature of 5 degrees Celsius, 500 in open burning at about 5 hours at a local burning site. The ash was allowed to cool and sieve to 75 microns. That is a chemical analysis of the waste tire ash was conducted using the XRF. Then the SEM works by aiming an electron beam to the surface of the specimen. When the electron beam strikes a solid object, the electrons are scattered or absorbed. The collection of these responses is what forms the SEM image. So crush sample of the WTA concrete cubes used for the compressive strength test were labeled and preserved for the microstructure analysis of concrete and to study the effect of WTA concrete. So the X-ray diffractometer is used to scan for the SRD analysis. A small amount of powder sample is put into the aluminum sample holder and a surface is finished smoothly. Then the sample are scanned by an X-ray diffractometer using CUK radiation at 400 kilovolt, 20 milliampere. Then the analysis is stepped at 0.04 degrees increment and continue for a period of 3 seconds. In X-ray diffraction, X-rays are scattered by atoms in a pattern that indicate lattice spacing of element present in the material analyzed. Once the X-ray analysis is completed, the scans of the analyzed using JET X-ray diffractometer software. So using the using jet peak intensities at different angles are compared with the database of different minerals and compounds. Compounds with peak intensities matching those of the scans are identified and the compound present in the samples are determined. So these are our results. Start with the microstructure of the WTA concrete. As already stated, SEM has become a useful tool in the study of concrete and its related materials. And it has been described as a versatile analytical tool capable of providing several different types of image, qualitative data related to porosity and cement paste composition, and information about the microstructure of the concrete. So for this study, the WTA concrete matrix, so according to figure 2, which is shown in the next slide, our SEM image of the control are 7 days indicating large clusters of light gray or brightest spots of anhydrous cement or calcium hydroxide crystals reflecting the early period of hydration of Portland cement. So OPC concrete at 28 days, shown in figure 3 on the other hand, shows more area of darkness of dark gray particles, indicating sheet-like habit of CSH, hexagonal habit of calcium hydroxide, aggregate, and the dark particles at the extreme point indicating voids. The SEM images also indicate some anhydrous cement particles throughout the brightest spots on the image. Overall, the SEM photograph of the OPC concrete at 28 days shows more CSH and calcium hydroxide than 7 days, resulting from the hydration process. Okay, so these are the calcium hydroxide crystals. Okay, these are some of the pores. We have the residual cement. Then we have the voids. We have the cracks. So these are the calcium silicate hydrates and the calcium hydroxide. Okay, so where am I? Sorry. Then the OPC at 28 days, shown in figure 3 on the other hand, shows more areas of dark gray particles indicating sheet-like habit of CSH, indicating the SEM image also indicates some anhydrous cement particles through the brightest spot in the image. So we can say that overall, the SEM photograph of OPC concrete at 28 days shows more CSH and calcium hydroxide than the 7 days. Then for concrete with 5% WTA, the morphology at 28 days curing shown in figure 4 indicated observed WTA cement hydrated paste with large voids as evidence of the dark patches of black areas indicating voids and the visible crack seen consistent with the explanation. The voids here appear larger than the OPC concrete. Residual cement grain appears brightest, but with less hydration product of calcium hydroxide and CSH due to dilution of OPC with low pozzanic action of WTA at 28 days. Then figure 5 also gives the SEM image of WTA concrete with 10% at 28 days curing. The effect is similar to that of 5% at 28 days, but with more formation of CSH and CH hydration product, as evidenced by the presence of light gray irregular shaped areas indicating calcium hydroxide crystals and dark gray area representing calcium silicate hydrate. This observation is consistent with explanation of 2 and 9 in the respective work on this. So this is figure 4 and 5. Okay. So this is figure 4 and 5. This is figure 2 and 3, as explained. So next is the XRD result. Researchers have so far supported the combination of SEM and XRD techniques in explaining the microstructure of cement base. In line with this approach, XRD analysis was carried out on the concrete and is used for this study. So figure 6 shows the XRD pattern indicating the development of reaction products on the control plane OPC concrete at 7 days. So at 7 days, as shown in the figure, the crystalline phases identified are portlandite, quartz, and calcite. However, the focal point of interest here is the portlandite content, since it indicates the progress of cement hydration and portlandite reactions. As expected, the concentration of portlandite, as observed in figure 7, is seen to have considerably reduced for the OPC concrete curing at 28 days. This may attribute to the progressively hydration process expected. This further explains the increased strength in the age of curing. So these are the figures. You can see the quartz, you can see the CH and the CC. These are all leveled. So at 5% WTA replacement, as shown in figure 8, for 28 days curing period, the portlandite content is either almost similar to or slightly lower than that of the plain OPC, indicating little or no contribution of WTA via pozzolanic reaction. So the presence of calcite in the mixes can be attributed to the secondary reaction of portlandite with atmospheric carbon dioxide. This is consistent with the explanation of number 10, in which there's work on palm oil, ash, and metakaolin ternary blood cement at elevated temperature. So at later ages, 28 days for the higher WTA content, as shown in figure 9, the amount of portlandite and unreacted progressively and significantly reduced, marking the progress of hydration and pozzolanic reaction. At 30% WTA, however, as seen in figure 10, the reduction in strength WTA concrete may be due to dilution of cement and at that level. So these are the figures, as we can see, as explained. And this is figure 10. This is the XRD pattern of 30% WTA replaced with concrete at 90 days. So in conclusion, we can say both SEM analysis and XRD result of WTA concrete indicate the occurrence of pozzolanic reaction between waste tire ash and cement, and that the waste tire ash concrete has more porous microstructure than the OPC concrete, especially at higher WTA. It also showed that the pores in the WTA concrete increase with increase in the waste tire ashes in the mixtures. Thank you. These are the references used. Thank you for listening.
Thank you, Dr. Adamo.
Yes.
If the audience has any question, we have time for one or two. Even this one was an interesting topic, like a sustainable future.
Yes. Okay.
I congratulate you and I wish you success in the future. And since we don't have any other question, I think we can continue with the third presentation. The startup Duili and Darper Kopuska, experimental study of FRP reinforced concrete beams according to ACI. Those authors have sent their recorded presentation via email, so I'm going to share it with you. And we can watch it all together. Just a second, I will share the screen.
Hello. Hi.
I think we have this presentation first. Can you see my screen?
Hello.
Yes, we can see it. Okay.
Hello, this is my presentation right now.
Just a second, Mr. Bavan. Normally, we were going to share the other presentation, the ID number 79, but since we are having a technical problem, we can continue with the paper with ID 90. Mr. Basan Bavan, since you are online, an advanced method of shear transmission from slab to steel beam of the composite beam subjected to combine negative bending and high axial tension. So the stage is yours.
Thank you, Chairperson. My name is Mayasan Bhavan from University Technology, Malaysia. I have passed this master degree at University Technology, Malaysia. Today, my presentation is an advanced method of shear transmission from slab to steel beam of the composite beam subjected to combined negative bending and high axial tension. So my presentation will be included 4 parts. First, introduction, research methodology, and results and discussion. Finally, summary and conclusion. In the introduction part, we will see the general part and background of the research. And in the research methodology, we will see the some of the experimental reviews and finite element model development with full and partial shear connection. And in the results and discussion part, we will see the finite element model validation and development of finite element model with wave strips and shear connectors. This is the new part of the research. And the effects of wave from steel strip with shear connectors in negative bending region of the composite beam. Then finally, summary and conclusions. So basically, the introduction and gap of the research in steel concrete composite beam with waveform steel strip. This is the new part. The mechanical shear stud connectors of the steel concrete beam, which are small device that transmitted high shear forces from concrete slab to steel beam, are key components in limiting ultimate limit state of the composite beam. This is usually everyone know the steel concrete composite beam component. Then there's a small device called the shear stud connectors. This device is the key element to run with the high shear force stud from concrete slab to steel beam. The function of the shear stud connectors in between concrete slab and steel beam is complex, and the ultimate limit state is influenced by the shear flow forces transmitted between steel beam and concrete slab. The shear connectors will function at partial connection, even the design of components developed for full shear connection. The cracking of concrete will be governing failure criteria of the composite beam in the negative bending region of the composite beam. So there's a 2-part, one is the partial shear connection and another one is cracking of concrete in the negative bending region. This is for subjected to vertical loads only, this concept. Then in addition, the function of shear transition between slab and steel beam subjected to combined negative bending and axial load. This axial load can be applied due to the inclined components like the car parks area, steel concrete composite beam, or the leeward side opposite of the windward side composite beams. So these composite components will be extremely influenced by the high axial loads. So now it's more complex due to this in the shear transmission due to this combined negative. If there's a place the negative bending region due to the high axial loads, then that composite beam subjected to both vertical and axial loads. Based on these circumstances, there's a hypothesis to learn and advance methods by different shapes of mechanical defects, which may influence positively to overcome this reduction that will be the gap of this research. It means that now the codes exist only the vertical loads. So as I explained that in some components situated in the car park areas and leeward side composite beam, this one will be subjected to combined axial loads. So these must be studied further. That is the gap of this research. In comparison of this composite beam with inclined and vertical strut connector, there may be advantages in the developed shear failure mechanism, where the shear strut connectors loaded with waveform stage strips. So the usual composite beam is like that: the steel beam, then the shear connectors, then the reinforcing bar and steel strip. So this one is existed in the courts only subjected to the vertical loads only. So now we are investigating vertical and axial loads. So we introduce one steel strip, like the waveform steel strip with shear connectors, to resist more shear transmission because of the axial loads. So this is some of the background of the research for the combined axial loads. I have also done earlier also with some other devices. So the gap is from the past researchers in the shear strut connected with wave shear strip in the negative bending region of the composite beam subjected to axial loads, such that this paper studies the shear transition behavior of the composite beam subjected to combined negative bending and axial tension. So some of the experimental review I took from the existing literatures, full connection and partial connection to steel concrete composite beam experimental labeled at CBF1 and CBP1. Then this experiment supported and vertical load only. So the ultimate case predicted by 220 kilonewton meter and one partial connection is 180 kilonewton meter. So I developed the finite element model by Abacus 3D finite element model. This is steel beam, shear connectors, and the concrete slab. Then all use the C3DR three-dimensional elements. Use the steel bar only use the truss element, and the interaction connector surface to surface contact interaction behavior I developed. Then the rebars all used as a embedded constraint. So the material, concrete material for the concrete slab developed by the proposed DC and Krishnan existing literatures, the equation I used to develop this compression behavior and the tension behavior used by the Europe code proposal. So for the steel components, rebars developed by the biaxial property, then the shear strut is only the 350 Newton millimeter square developed. Then the steel beam developed the nonlinear behavior also exactly we developed for the steel beam. Based on the prediction for the two full shear connection and partial shear connection, they're almost very close to each other. It's only 1%, 2% deviation with the experimental analysis. So we are concluding this model can be used for the parametric studies. So then the research knew that gap of the research. To learn the gap of the research, we introduced this waveform steel strip to the composite beam. So we introduced this waveform steel concrete composite beam wave strip in addition. So the validated finite element models were then brought with introducing of wave strip with shear strut connection, and a research study was carried out in the determination of effects of shear transmission of the composite beam with full and partial shear connection. So the effects of wave strip with shear strut connectors in negative bending region of the composite beam. Strut shear connectors, which include a head and shank, are a small mechanical defects, where the purpose of head is to avoid the separation in between the major material components of the concrete slab and steel beam. The slip, which occurs because of the deflection of the composite beam, induces a gap in between the concrete slab and the shank of shear strut, so that the failure of the composite beam will occur as due to the slip in between the concrete slab and steel beam. In the vertical load, there will be the gap in between the shear connectors and the concrete slab. This due to the slip sleep. So this axial tension also will induce excessive sleep. So the gap will be more. So we are introducing the wave strip to control, to resist the composite beam to get higher ultimate state. So the studies from existing literature show that cracks induced in the magnetic bending region of the composite beam and full shear connection will not be functions in the composite beam. So the developed model labeled that, so we developed this model full and partial and labeled, and we focus on all the behaviors, all the failure behaviors, separation of shear stress, sleep of shear stress, deformation of shear stress, and concrete crushing and cracking, buckling of steel beam. And we check all the behavior to which one is a governing failure criteria in the composite beam at this stage. So the nodes of the concrete and the chunk of shear stress were monitored in the zone of gap induced by slip. It can be noted that the value of shear forces was associated to the magnitude of the slip. So we are monitoring the magnitude of slip with earlier condition and the current condition. Based on this, obviously composite beam with wave strip in both conditions such as full shear connection, partial shear connection were improved. Magnitude of slip was extensively reduced, and the beam showed that the axial load can be resisted by wave strip. In other words, the excessive slip induced by axial load can be resisted by wave strip, and the ultimate strength of the composite beam can be improved. The cracking in the magnetic bending region was postponed in the application of wave strips. It can be noted that first failure modes are concrete cracking and shear stress deformation in the composite beam subject to combined magnetic bending and axial loads, and this criteria can be postponed by the application of wave strip. This we found based on the research. Based on this one, we draw the summary and conclusion. The nonlinear finite element model study was presented to simulate the shear transition behavior on the negative bending region of the composite beam with wave strip. Wave strip with stud shear connectors with nonlinear material models of steel and concrete composite components were incorporated into finite element model, which was carefully calibrated against test data of full and partial shear connection. In comparison of the installation of wave strip with shear connectors, the FE model results indicate that the load carrying capacity developed with postponing the failure criteria occurred in the components of the composite beam. So these are our summary and conclusion today, and some of the references I used. Then thanks everyone to watching my presentation.
Thank you, Mr. Brown. If the audience has any question. All right, then we can continue. Thank you again. We can continue with the previous presentation that we had this technical problem. I'm going to share it again. Okay.
Hello everyone. Today we'll do the presentation of experimental study of FRP reinforced concrete beams according to ACI. This is an experimental study which was conducted at Laboratory of Civil Engineering at University of Pristina. The use of FRP bars is on the rise, especially in developed countries like USA, Canada, Japan, Germany, and other countries. FRP bars are mainly used for reinforcement of road layer, bridges exposed to salts, reinforcement concrete piles in acidic soils, slab reinforcement for industrial structures. Also, reinforcement beams for railways with magnetic system and soft eye technique TBM, FRP reinforcement for diaphragms wall. A little brief history about the first studies and first use of FRP. In 1960 starts the use of FRP bars in a test form. In 1997 the first document for the use of FRP bars, and also in 2001 American Concrete Institute ACI. Also, at least recently in 2012 Eurocode. We should mention that this experimental study is done according to ACI codes. Comparison of FRP bars and conventional steel bars is the main point of this study. By stress-strain curve we can see the behavior between conventional steel bars and FRP bars. On FRP bars is noticed a high tensile strength, about 80% more than steel bars, but at FRP bars we have a brittle failure and not a classical curve or of stress strain like steel bars. This is the reason why at FRP bars the serviceability limit state is limited at 33% of maximum strength of the beam. FRP bars are consisted by two components, fibers and resin. The naming of FRP bars is according to the type of fiber. The main composition of FRP bars are GFRP, CFRP, BFRP, and AFRP. Which mean the most common types are glass fibers, carbon fibers, basalt fibers, and aramid fibers. From the table we can see that carbon fibers have the highest tensile strength and modulus of elasticity. The most common types of resins are epoxy resins, polyester resins, vinyl ester resins. The manufacture process is called PULTRUSION. This process goes through several stages like fiber creel, guide plate, resin bath, preformer, forming and curing die, pulling system, and cut of saw. The procedure of testing consists of first by testing the mechanical properties of GFRP and CFRP, then by testing mechanical properties of concrete, and finally by testing of reinforced beams with GFRP and CFRP on overall. The flexural capacity of an FRP reinforced flexural member is dependent on whether the failure is governed by concrete crushing or FRP rupture. The failure mode can be determined by comparing the FRP reinforcement ratio to the balanced reinforcement ratio, that is, a ratio where concrete crushing and FRP rupture occur simultaneously. Now we can see the characteristics and reinforced of different set of concrete beams for percentage of reinforcement and bending moment. In this slide we can see a sample of beam during examination. On this table is presented the behavior of the testing beams for different type of reinforcement. It is noticed the percentage of serviceability limit state is no more than 33% of the maximum strength of beam. The balanced reinforcement ratio and the nominal flexural strength defined in the presented sections can be obtained by using a sectional analysis in different stages of SLS theory, including the percentage of this ratio. In this table are presented the cracks and deflections parameters in testing beams for SLS, 75% ratio and 100% ratio. Finally, conclusions. At RC beams with GFRP bars is noticed that with increasing bar diameter increases their bearing capacity and decreases their SLS. Vice versa, at RC beams with CFRP bars is noticed that with increasing bar diameter increases their bearing capacity and the value of SLS. The use of GFRP bars in the construction nowadays is difficult to achieve as a replacement of steel bars due to the low modulus of elasticity and characterized by great deformations. The use of CFRP bars as a direct replacement of steel bars is difficult to achieve because of the poor bonding with concrete. With the improvement of adhesive properties of concrete bars from different manufacturers, the use of these bars can be increased because they have a relatively elastic modulus of steel. The use of these bars at this stage is limited due to some properties that may have been improved in the future by different manufacturers. These types of bars in general at this stage can be used for constructions that do not have rigorous SLS conditions criteria, especially their full use instead of steel bars in skimmers subject to aggressive ambient conditions such as salt, water, and so on. Reference, and thank you for your attention.
Now we are going to continue with other presentation, improvement of flexural strength of reinforced concrete beams using CFRP wraps, that it will be done by Mr. Geksena. Mr. Tsena, stage is yours.
So, hi everyone. I hope I'm. Are you listening to me? Just a second.
Yes, yes.
Okay. I'm continuing. So today I'm going to present the improvement of flexural strength of reinforced concrete beams using CFRP wraps. This experiment was done by Professor Rania Mustafaray, me, Geksena, and my colleague Alexander Nikol. So the outline that I'm going to present have 5 chapters. So I'm going to introduce from chapter 1 to the chapter 5 to the conclusion. The problem statement. The problem statement was the damage of reinforced concrete buildings due to natural and man-hazard mates. So the degradation of concrete elements through the time, the corrosion risk of steel elements, and the change of occupancy, so increase of number of stories without a proper engineering study. The objective. The objective is the main objective of this experiment is to see the effect of CFRP wraps to evaluate the class of concrete and understand if it is worthy structurally and economically to repair and reuse damaged beams. Another objective is to evaluate concrete compressive strength using non-destructive and destructive techniques. So these processes were done conducting tests such as bending reinforcement, Schmidt-Hammer test, core drilling, and compressive strength of test. The scope of works, 3 beams of 0.21 times 0.27 and 2.5 meter dimensions of concrete class by C2530 were built. The beam analysis and detailing were done in tower and arm CAD from Radimpex software. Then we made the test setup, the application of CFRP wraps, and the comparison of expected results and experimental results. Also, we did the difference between non-destructive and destructive technique of quality control of concrete. Carbon fibers. The first time that the carbon fibers were used outside the research studies was at Ibach Bridge at Lucerne in 1991. This material is used a lot since it is a very strong material that is also very lightweight. Carbon fibers are multiple times stronger than steel and twice as solid. The experimental results show that the use of CFRP wraps as external strengthening increases the ultimate load, crack pattern, and deflection of the strength beams. Also increases the flexure, shear, and compressive strength of concrete beams, slabs, columns, wooden beams, masonry elements, etc. So this is the figure 1. This is the carbon fiber that we used on our experimental. We also used epoxy primer and epoxy resin adhesive. Epoxy primer is a 2-component solvent-less epoxy system which, when mixed, yields a penetrating medium viscosity primer. It is used as a primer prior to the use of epoxy resin adhesive when used in conjunction with carbon fibers. Epoxy resin adhesive is solvent-free, high-strength adhesive developed for carbon fibers. It is used for bonding of VRP wraps on concrete, steel, and wooden surfaces. Features and benefits of epoxy resin is because it is easy to apply, low viscosity, high strength, and solvent-free. Chapter 3, the building of the beams. The mixed design ratio was calculated for the concrete class of C2530, the Salmon grade 42.5. The table 1 is it shown the mixed design ratio, and on the figure is it shown that cross section of the beam that we built. Test setup. As shown in figure 6, beams were tested on 4-point load with a clear span of 2.2 meters and internal span of 0.9 meters. 3 digital vernier calipers were fixed on the bottom part of the beams to measure the vertical displacements. The 4-point bending static loading was performed using hydraulic pump cylinder. Application of carbon fiber reinforced polymer wraps. Before we made the order of carbon fibers, we first made a sketch of how to place it and how much we needed. Epoxy primer is the first material that was applied to the beam for strengthening it with CFRP wraps. Epoxy primer was applied by roller to the prepared substrate at a coverage of 4 to 6 meters squares per kilogram. Then it was allowed to become tack-free before application of epoxy-based resin adhesive. The application of CFRP wraps. So epoxy-based resin was applied in 2 phases. First phase before applying CFRP wraps, and second phase after we applied them. Then we used a smooth roller to apply with a thickness of 0.8 to 1 millimeter. Then we laid down the CFRP wraps while the adhesive is still moist on the surfaces. After the installation of CFRP wraps were completed, we waited 3 days to test them because they had to be strengthened. Testing of beams. The 3 series of bend experiments were conducted using beam samples of the same size. The first test was done on a simple reinforced concrete beam. The second beam was initially cracked and then repaired by applying epoxy resin strength with CFRP wraps and was tested again. The third beam was applied on a non-damaged reinforced concrete beam, but just strength with carbon fiber reinforced polymer wraps. So this is the beam 2 after CFRP wraps were applied, and another bending test was applied again to see the effect of CFRP wraps. So this is the first bending. This is the second bending of the same beam. The third test was applied on a non-damaged reinforced concrete beam, strength with CFRP wraps. Also, it was planned to reach that this beam will reach the highest carrying capacity compared with the 2 reinforced concrete beams. So these are the pictures by applying the beam 3. Quality control of concrete. We also made the quality control of concrete by 2 techniques. The first technique was non-destructive technique by Schmidt-Hammer, and the second technique was destructive technique with cold draining. The core drilling technique is carried out by means of a carriage consisting of a cylindrical cutting of the concrete elements that have been previously determined to be analyzed. In this case, 3 columns and 3 beams were chosen from with 75 millimeter diameter cylindrical concrete samples are taken. We also made the compressive strength of that samples, and now is the results in the batting of ray-formed concrete beams. Beam 2 reached the ultimate load force 176 kilonewtons, that is 38% greater than the first result of the same beam, but not strength with CFRP wraps. The beam 3 was not pre-cracked, but just strength with CFRP wraps, with the same procedure as beam 2, and then was tested. The ultimate load test force was 215 kilonewtons. That is 22% greater than the ultimate load capacity of beam 2 that was repaired with CFRP wraps. Figure 21 shows that all beams attached to additional CFRP wraps conducted considerably better in terms of strength and stiffness than the non-strength beams. So beam 3 reached 215.8 kilonewtons, that is 56% greater than the ultimate load capacity of beam 1. We can see also the graphic of the cracks, and we can compare the graphic of beam 3 with the graphic of beam 1. These are the results that shows that beam 3 is 1.57 times stronger than beam 1. Also, we got the results in the bending of these reinforcements, the experimental bending. And we got the results of non-destructive techniques that shows that the quality of concrete was from 30 to 36 megapascals. These are the results of the core drilling techniques. Because it is cylindrical sample, we got them 25 megapascal, which is also the C2530 grade. And we have after all the experimental, we got the conclusion. Based on the specific findings of this research, the following conclusions may be drawn. That is, it is recommended using CFRP wraps as a reinforcement material for damaged structures. CFRP wraps can be used as a reinforcement to improve the flexural behavior of the beams. The CFRP wraps have increased the stiffness and maximum load of the beams. The crack width and the deflection have decreased for the strike beams, and the ultimate load test of the strike beams was 1.57 times greater than the control beam, that the beam 1. Also, there is a slight difference between Schmidt-Hammer compressive strength and the compressive strength of the core drilled concrete samples. The Schmidt-Hammer results are used only for general and fast evaluation. For more specific results, we have to do the destructive tests, which are more accurate. Thank you very much. I hope you could understand me.
Thank you, Mr. Chena. If you have any questions, we have some time for questions and answers. It seems that there are no questions, so if Mr. Nela is ready, we can continue with his presentation. Structural assessment of the southwest wing timber roofs of the Loretta in Prague.
Yes.
Okay,
Hello,
the stage is yours.
Can you see my screen?
Yes.
Okay. First of all, thank you for having me and organizing this wonderful event. My topic is on structural assessment of the southwest wing of the timber roofs of the Loretta in Prague. This is the outline of my presentation. The Loretta in Prague is a pilgrimage complex of buildings, which consists of these small buildings, as can be seen on the picture on the left, and the site is located on Prague 1 district in the wonderful city of Prague. The main complex is consisted of the Santa Casa in the middle. Just one. So here in the middle, which is a copy of the original Santa Casa in Italy. Then we have the chapels and the cloisters and at the edges and on the middle of these cloisters here. And the Church of the Nativity of Our Lord, which is concentrated here on the far back of the complex. One interesting thing is the murals on the cryptography under this church, which are amazing and are open to the public some twice a year or once a year. On the front is the main facade, which is a wonderful work of the famous architects Diessenhofers. And on the main facade is this wonderful tower, which consists of the bells original from the beginning of the tower, and they are still played originally as they were played in the past. On this front part of the building, there is hidden also this treasure, which is the most valuable treasure of Prague, which is called the Prague Sun and consists of around 6,000 diamonds. This is a historical development of the construction of the complex for the Loretta in Prague. So in 1626, it was laid the first stone, and then the cloisters were constructed around 1634. And the tower was construction was finished in 1646. So you can see a model of this hypothetical model of the building at 1664. On the back, you can see the Church of Nativity, but without the extensions to the back. So just a simple church. And then on 1685, two more chapels were added. Our Lady of Sorrow and Saint Anne. And on 1699, there were added two more chapels, the Holy Family of the Holy Rod. And the tower was changed from to an octagonal form from a square base form. And this is the model of 1699. Then the church was extended to the back and two more chapels were added, Saint Antonio of Padua and Saint Francis of Seraphino's. On 1722, they contracted the Diessenhofers to make some arrangements on the facade, and they changed the facade to a Baroque one. And they wanted to diminish the effect of the fortification, which was a very distinct, let's say, style in those times. So finally, this is a model of 1720, where the cloisters were elevated to a second floor. The fortification effect was diminished, and they added some more Baroque effects to the building. From a dendrochronological dating of the timber roofs on the top of this building, they were able to see how when the wood was cut and when they were placed on the structure. So it's not very accurate in terms of the base of the structure, but in terms of the roof, it's very interesting to see when the roofs were built. And here, based on the historical development and on the dendrochronological dating, I was able to make a stratigraphical model of how the complex was built. In the one part of the roof, because the complex is very big, so we were concentrated on this part of the roof. We were able to do some NDT, non-destructive and minor destructive testing, how I like to call them, non-intrusive tests. And we were concentrated on these frames which showed more areas of interest. So they are named as 1, 2, and 3. We saw that some the main connections are carpentry connections made of wood, and some elements were removed. So they were removed, and we can assume that there were made some changes, some elevations, or some strengthenings. So we saw some past interventions that they added these columns here to strengthen these rafters. They introduced some holes to fix, so to put something against insects. They introduced some metallic connections, also some fireproof measures, and so on. But then we found out that there are also some large deflections seen on the frames. So we did the visual inspection according to this standard, and we, based on the knots, on the slope of grains, the growth rate, the fissures, the geometric features, and using a resistograph, we were able to make these circular rings of the trees. Using all of these parameters, we were able to find some qualitative data to get mechanical parameters for the timber, which are these here. But then we also did some moisture content testing in the internal of the beam. So we made some holes and checked the internal measurement, and also superficial measurements. And we were able to see that the maximum moisture content is lower than 14%, which is not so severe for these type of structures, since they do not present any moisture damage or reduction of compressive strength of such features. Afterwards, we did some resistance micro drilling through a resistograph, and we were able to find some holes on the rafters and on the columns, and we made some assumptions of why they were there. Afterwards, these are the results of the resistance micro drilling, and through some correlation equations made from Kloiber et al., we were able to find the compressive strength and the density of the timber elements. Afterwards, we used this innovative tool from Professor Derdatsky, which is the loading jack. So the loading jack is introduced inside the wood, and at 4 sections, it does some sort of a compressive test in situ to the timber elements. And you can find that you can find out this graph, which shows the force and the deflection relation. And also you can compute the modulus of deformability. Afterwards, again, from Mr. Kloiber experiments, we were able to correlate these results to compressive strength, to modulus of elasticity, and to the density. So using all of this data, visual resistance microdrilling, and all those that I presented before, we were able to get a class which best suits this timber beams on the structure from the norms of Czech Republic. So we get a class of C20 for timber. Afterwards, we did some load analysis on the timber. So these are the loading conditions. I will not get into details. And then for this part of the roof, we did a 3D model. We introduced the loads, and then to have it more simple, we changed to a 2D model so we could make some modifications. And we introduced 3 scenarios. So the first scenario is before the intervention, because we saw that in the last floor there was a concrete floor added not so recently. And before the interventions, we introduced these supports here, which have some axial stiffness as a horizontal constraint to introduce the thrust of the horizontal beam, which may have been here. And on scenario 2, we remove this beam, and this support is free to move on the horizontal direction, because this is introduced to represent the interventions at that stage. And the scenario 3 is the current state, where they introduce this short column and this strengthening horizontal beam. But to have these deflections transfer on this truncated rafter here, and to introduce the wall, which is on the right side, we had to do some contact modeling. But since we were in a commercial software, it was not so easy. So we had to make sure that we transfer the deflections and the friction. And we introduced some rigid elements which have no weight, and they work only in compression so that they can transfer the deflection from the main rafter to the lower rafter. Then the friction transfer was done with some analysis of how much of this force is transferred as a shear force on this beam, and this way we introduced the friction to the truncated rafter. Afterwards, we found these results for the 3 scenarios. So this diagonal here is the diagonal strut is working only under tension, and in the scenario 1 before the intervention, only under compression, sorry. We found out that this diagonal strut was working, so it works under compression, and the deflections were not so big, but then we saw these deflections on the main rafters, so we assumed that they had to do some interventions. And during the interventions, as I removed these supports here, we saw that this side moved a bit, and then this diagonal strut no more worked as a compressive strut, but worked as in compression. So because this is made of a nonlinear beam type, it doesn't take tension, and this side moved and introduced these deflections, which were seen also on site. On scenario 3, after the strengthening, we saw that everything was working properly, and we made this the stability analysis, and we were able to see that the structure is actually stable this way. So with this wonderful drawing, I would like to conclude that we were able to make these hypothetical assumptions from the historical background, but also from the diagnostic tests. And then through structural analysis, we made the final hypothetical assumption, which is highly to be true, but it's just a hypothetical assumption. But in any case, the structure is safe, and we conclude it that way. Thank you very much for your attention.
For that interesting presentation. If the audience has any question.
I would like to ask one question.
Yes, Professor
Possible?
Yes.
First of all, I congratulate Bledian for this very nice presentation, especially also I think it's related with the nature and the quality of the building that he presented. I'd like to know whether this was a part of a certain thesis or kind of major research study, or a kind of project-based on the side something.
Okay. So mainly this the main project of the building for the Loreta complex is based on a bigger project from the institute in Czech Republic. But my focus and my part of the study was only for a thesis, for a master thesis in historical monuments.
Okay, it was a very nice presentation. Thank you.
Thank you very much.
Well, thanks once again. We are going to continue with the next presentation. Mr. Marcel Bled and Professor Hüseyin Bilgin with the use of incremental dynamic analysis for the seismic performance assessment of reinforced concrete frame structures. Please, Mr. Bled, the stage is yours.
Thank you, Professor, and thanks to everybody being here today, following and participating in our conference. So my study is related to the use of incremental dynamic analysis for the seismic performance assessment of reinforced concrete structures, which actually has been a part of my master thesis. In this study, we are going to evaluate the seismic performance of two buildings, reinforced concrete buildings. One of them is low-rise building, and the other one that we have selected corresponds to the mid-rise building. And actually, we are using one of the most development analysis known as incremental dynamic analysis under a suite of 20 ground motion reports. So for our scope, we have used Zeus NL as a suitable software in order to model both buildings. The buildings are representative of a low-rise and a mid-rise building, both selected from the Albanian building stock. one of them 3-story, and the other one have been selected as 7-story building. The models have the same plan view, both symmetrical in X and Y direction, and also selected as frame reinforced concrete buildings without having any shear volume of them. The Zeus software is used as a suitable platform, which actually is capable of conducting finite element analysis, which is developed especially for earthquake engineering purposes. It is capable of modeling steel structures, reinforced concrete structures, as well as composite structures under the application of static and also dynamic loads. It can also consider geometrical nonlinearities, and also the material can be composed of elastic material or inelastic material. This software basically considers the reinforced concrete elements in different fiber approaches, such as unconfined concrete fiber, the confined concrete fiber, as shown in the image here, and also one fiber is developed especially for the steel fiber. It is also capable of running incremental dynamic analysis, and this is very important for our stage, since this is one of the 4 analyses that we have conducted in our master thesis. As a new and well-known analysis, incremental dynamic analysis, basically it is used in order to evaluate the seismic performance of structures. It is considering a suite of ground motion records, and the idea of incremental dynamic analysis basically is to increment the peak ground acceleration in order to push the building until it fails and it reaches the global instability or global fail limit state. It has been introduced in 1977 by Cornell and Bertero, and later on it has been continued to develop more by other researchers. And one of the researchers that actually has developed a very clear methodology is Van Vatsikos, that we are going to present in upcoming slides. So this is the methodology that we have followed by a Greek researcher, Van Vatsikos. It is very crucial in order to follow a specific methodology for the generation of incremental dynamic analysis curves, because basically that will be a very sensitive case, especially for the interpretation of the results in the beginning. So in the beginning, we are going to create a suitable structural model. So for our case, we are using Zeus as a capable and powerful software, which actually runs the dynamic, nonlinear dynamic analysis very fast compared to the other softwares, and also is capable of running our incremental dynamic analysis as well. Secondly, it's important to select a suitable ground motion records. So based on different researchers and different studies for mid-rise buildings, we are supposed to select at least 10 to 20 ground motion records. So for our study, we have selected 20 different ground motion records, basically ranging from 0.042 G to 3.5 G acceleration and showing no directivity influence. And this is important, especially for the intensity measure that we are going to present later on. The nonlinear analysis procedure is basically what we have presented before. So it's same as time history analysis. The only difference is that incremental dynamic analysis is going to plot the capacity curve of the structure under the increment of peak ground acceleration for different analyses that it can conduct. So basically it starts to run the analysis, and in the beginning it will present the values, the results as a single dot, and then considering the increments that has been specified by the user, it's going to replicate that analysis until the global instability or global failure of the structure is reached. As you can see here, these steps are the same, but actually the damage measure is going to change with slow steps in the beginning, and then with the same increment in the intensity measure, that damage measure is going to have a very huge, let me say, difference in the damage measure in order to show the flat line or global failure of the structure. Then after the global failure of the structure is reached, then the other analyses are going to be meaningless. So basically, we will need to interrupt the analysis up to that point. The selection of intensity measure and also damage measure has been introduced by different researchers. It can be taken as different parameters, but actually the most known intensity measure is going to consider that we have considered also for our study 5% dent representative of first mode spectral acceleration, and the damage measure is the maximum global drift that we are considering for our buildings. The brown dots that you are showing in this graph actually represent one analysis taken from incremental dynamic analysis, and later on we are going to use interpolation in order to show the curve of incremental dynamic analysis. Basically, this step requires two different algorithms. We can either choose hunt and fill algorithm, presented before by researchers, or a superspline algorithm, which is more user-friendly, and it can be also utilized by the means of Microsoft Excel. So in our case, we have utilized this method. Simply by using Microsoft Excel, we have prepared all the incremental dynamic analysis. According to the performance-based earthquake engineering, at least three limit states are needed to be determined in order to consider the results at the end of all the generated incremental dynamic analysis. So we are starting with the immediate occupancy, collapse prevention, and then global instability. According to the FEMA guidelines, especially in this case, FEMA 356, immediate occupancy is going to be determined as 1% of damage measure, which will correspond to 0.01, the collapse prevention to 10%, or 20% of the elastic slope. And in the end, the global instability, which is actually the global failure of the structure, will be represented by the flat line. Well, basically, the global instability is obvious from the graphs, and also immediate occupancy is also very easy to be found, and we can read the values from the graph because this is safe procedure, corresponds to 1%. Well, actually, the collapse prevention should be considered as 10% or 20% of the elastic slope. And in order to find the 20% of the elastic slope, we will need to develop a special algorithm in order to calculate those results. And considering that the curve might be very complex for the incremental dynamic analysis, it may happen that we may have different collapse prevention points. And basically from the research and previous studies, the collapse prevention point should be considered the one which is happening in the loss or before the 10% of damage measurement. For this case, we are using an algorithm taken from the Bezier curve, which actually has been used especially in computer graphics and is very easy in order to interpolate the results and find the respective values, especially by using a piece of script or computer programming. ETA curves, especially for the last stage, which belongs to the global instability, actually it is shown by the flat line or the horizontal line in our graphs. And might be different cases. For example, in the second case, we can see that we have at least two flat lines, which actually the software may give these kind of resurrections and then continue with the second or more multiple flat lines. For these cases, we are going to reject all the other flat lines after the first one occurred. It is the other step is to define all the immediate opposite points. As you can see here, we have defined by the blue cross and also the collapse prevention. As you can see from the graph, some of the collapse prevention has been defined at 10% of damage measure because the slope, 20% slope, has not appeared yet. So this might be the boundaries, the ultimate limit of the collapse prevention. For the other ones, we are selecting the 20% of the elastic slope. And then the flat lines represent the failure of the building, which is also the global instability limit state. It is proposed also by the researchers that in order to interpret the results, it gives much information on the fractals, either fractals, which are summarized as 16%, 50%, and also 84%. We have observed that for some cases, some of the records actually has forced the low-rise building to fail before the mid-rise building, and this can happen due to many reasons, as for example, the inherent characteristic of the ground motion record, resonant effects, and may be other reasons as well. What is important here is that from that incremental dynamic analysis, either from the graph and also from the tabulated values, we can read for any limit state or any record all the peak ground acceleration which actually has reached that limit state. And also from the summary of either fractiles, we can basically read from the graph immediately. For example, if we are interested to know the, let's say, the maximum drift that happened to that building at 1G for 16% of the samples, we can immediately read from the graph, and then we can come to a specific values that represent that that curve. Also, the values are tabulated for all the either fractiles and also the incremental dynamic analysis curves. So just to summarize, two buildings have been considered in our study. The mathematical model has been utilized under the environment of Zeus software. And as these analyses require many runs, actually in our case, above 1,200 nonlinear analyses have been conducted in order to generate the incremental dynamic analysis curves and also the fractiles. We have used the guidelines of FEMA 356 under a suite of 20 ground motion records. The methodology is very important, especially to generate the incremental dynamic analysis curves. So we have prepared a specific algorithm in order to complete the methodology for our study. And in the end, we have summarized all the fractiles into 16, 50, and also 84% according to the previous studies. So the immediate occupancy, collapse prevention, and global instability has been defined for all the curves. And as you can see here, this is the list of records that actually have pushed or forced the low-rise building to fail before the mid-rise building. From the either fractiles, actually we can read much information, and this is a very wide field in order to interpret the result. However, this study can even continue more to produce the mean annual frequency of the exceedance, especially for different limit states. However, this for sure requires more time and more analysis to be conducted in order to achieve our goals. So thank you very much. In case you have any question, it will be a pleasure to answer your questions.
Thank you, Mr. Leder. Any questions from the audience? Okay, then I would like to make an announcement. The presenter number 86 will not be presenting, as well as we received some other emails that some of the other papers cannot be presented in the fourth session due to some reasons. So we thought to merge the session 3 and session 4 in one. So we can continue with Anna Unitsina and Lorena Lika, paper folding biokinetic facade, application of bat-wing-inspired facade design to the building of a Mediterranean university in Tirana, Albania. If Lorena is here.
She's honest.
Yes, I'm here.
Okay, you could start the presentation if you wish.
Is it open?
No, we see only your camera. You could share your presentation on the screen.
Sorry.
Okay.
So my presentation is the paper folding biokinetic facade. It's an application of the wing-inspired facade design to the building of the Mediterranean University in Tirana, Albania. First, I want to thank also Professor Anna for the project. The topics of research are
The topic of the research are application of a foldable and nature-inspired kinetic facade onto the contemporary building in Tirana, and the evaluation of its advantages in terms of light control and reduction of the cooling loads of the building. The paper starts from the overview of the history of kinetic architecture. Paper folding is selected as a technique, and biomimicry is an approach which helps to design the repetitive units of the facade. The first term used was biomimetics, which was used to describe the transfer of form to biology, from biology to technology. Then it became biomimicry. Another term used was bionics, which then became associated more with robotics. And folding can be found in living organisms, such as insects and bird wings, and it is also typical for the leaves and petals. The folding pattern from nature can be transferred into the artificial structures. The pattern of folds can be organized in such a way that it provides the opening and closing of the material sheet only in one direction. Folding method can be used in order to compose modular and responsive built-in schemes. We're going to use origami, which is a Japanese paper folding art, for the development of a foldable facade module. Here are some examples of the biokinetic facades, such as Al Bahar Towers, Kiefer Technic Showroom, Ocean Pavilion, and Hydroskin Pavilion. The chosen object to implement this facade is the Mediterranean University of Tirana, since the whole facade is made out of glass and the glare is very bad, and the louvers that are currently in this facade don't work well at all. The chosen form to translate is the bat arm, because of its flexibility and also because of the three main conditions that we want for this project: open, semi-open, and closed. And it also has the most fluid movements, fluid and smooth movements. These are the first models done starting with the simplest movement of the bat wing, and then going to the more complicated movements and structure of the bat wing. These are the stages of development of the geometry of the facade module. First, we start with a rectangle piece of paper with dimensions and sides in 1:2 relation with each other. Then the triangle is divided in the middle, which creates two equal squares. These squares get divided once more by diagonal, which is the green interrupted line, through each of them that pass through the upper middle point of the rectangle and intersect with the line we drew in the middle. The point where they join mimics the elbow joint of the bat wing. We have 4 equal triangles and divide only 3 of them in the middle, with a line that starts from the angle where the other lines are intersecting to the middle of the length facing that angle. The left triangle is left untouched for now because it serves as a part of the forelimb, which allows for the opening and closing of the bat wing. The magenta lines, which have been constructed until now, make up the part of the bone structure of the bat wing. For the part of the membrane, it is needed another division because of the flexibility of said membrane. The cyan lines are taken from the point where all the lines intersect to the middle of the length in front of each angle of the big isosceles triangle, formed by extending the shortest line to make it the same as the longest line, because we need symmetry in all the folding of the paper. To further deal with the flexibility of the membrane, there are needed these little triangles which will fold on itself and give the dynamic movement to the module. To build the triangles, first we have to find the middle point of the bigger triangles. This middle point is found by constructing a line from each angle to the length in front of the angles. The intersecting point, which are marked with a green circle, is connected to the edges of the bigger triangles. So to find the valley, which is the line that are going to go down during folding, we need to find the right angle for the bigger triangles to fold in a symmetrical line. To find this triangle, we take into consideration the small triangles formed at the base of the bigger triangles. We need to find the symmetrical line of the small triangle. From math, we know that the symmetrical line of an isosceles triangle is the line from the smallest angle of said triangle to the base, who form a right angle. So, to find the right angle, we elongate the smallest length of a small triangle and make it equal to the length in the front. Then we create another triangle, which is an isosceles triangles, and easily find the right angle we need and find the symmetrical line. The point where the symmetry line of the small yellow triangle intersects with the base of the bigger triangle is the point we need to connect the middle point we found before. Now we have found the correct angle where the membrane will be folded. The bigger left triangle that was left untouched until now mimics the forearm of the bat. Because of this, we only need to find the middle point on the folding lines, following the same mathematical rules as above. The difference in this part is the direction of the fold, which allows and creates the fluid and dynamic movements and also the ability to completely close the module. In the last image is the finished tessellation of the origami bat wing for our module. The red lines are the mountains, which are going to be the foldings that are going to go up, while the magenta lines are the valleys, which are the foldings that are going to go down. The facet will be built in a structural grid where that is going to envelope the whole building, where the forearm of the bat is going to be fixed as shown in the picture below. So only one part will be fixed, while all the other part will be fluidable and be able to move. For the simulation of the facade module, I have used Grasshopper, and here you can see 6 stages of opening of this module. Also, I have used Ladybug, which is also a tool of Rhino, to get the data of how well this facade skin responds. And I have the spring equinox, fall equinox, summer solstice, and winter solstice, which are the main difference in the year with heat, glare, and temperature. And also done a simulation with the opening of the facade in all 6 levels of opening, 6 conditions. So we have in first the glass facade as it is, the glare from that. Then we have with 0% opening, 10% opening, 3% opening, 50, 70, and 90 of the facade that is implemented in the building. We can clearly see the difference. So some conclusionary remarks. Biomimicry is the concept which makes possible the study of the chosen form and finding of the way and the idea of the mechanics for the project. The chosen form of nature to study was a bat wing because of its flexibility in movement and the way it can take different positions during flight. The project module needed careful mathematical calculation to be built in a way that allows the parts of the module to be folded correctly with no extra edges. The finished product has to remain in position, open, semi-open, and closed, and other sub-positions or way of openings in different degrees. The model is very flexible, and the opening is done by a light and heat sensor attached to it to make the facade direct to the environment. These are some of the variation of the facade panels composition for different way of putting them together. Thank you. I also have a little video to show This is the simulation of a facade.
We cannot see it.
You cannot see it?
So stop share and then share again your video or your screen.
Just a minute, please.
Let me help you. Share it again.
Yes. Is it okay now?
Yes.
Yes.
Okay. So this is the simulation done with Grasshopper. Okay.
Thank you, Ms. Egan, for your presentation
Thank you.
and for the interesting topic. If the audience has any question, we have time for one or two. Okay, then thanks again. We can continue with the next presentation from Antonella Andoy and her colleagues, an innovative and practical solution for the surface and volume computations in land surveying. Antonella, the stage is yours.
Thank you, Professor. Greetings, everyone. Firstly, I wish you are all doing well during this hard pandemic time. May I share my screen now? Can you see it? Okay. So this is our project, an innovative and practical solution for the surface volume computation in land surveying. So our team involves Nertita Suri, Ileriana Haidar-Martai, Antonella Andoy, civil engineering students, and Professor Marcel Leti at Epoca University. So nowadays, earth and excavation works are among the most common and important activities in the civil engineering field. Surveying is also an important field in civil engineering, which involves to determine the relative positions of the points on the land surveys, as you may see from the figure in here. So the volume calculation has always been an important task in the land surveying. Many researchers have been dealing for many years to find the most relative and appropriate method in order to increase the precision of the volume calculation and data computation using various mathematical methods. There are three main points: site measurements, office works, and then which will give us the result and the product. The process of our work, which most of civil engineering may know, it's a manual one. We are familiar with it. So we start with an area, a terrain grid. We conduct measurements. Each point, each elevation is measured by total station. Then all this gathered data is tabulated in an equipment. So we select then an appropriate method to elaborate data. And lastly, we compute the surface, as shown in this figure, and the volume. As civil engineers, we would like our calculations to be precise, also reduce the cost, and consume less time conducting an analysis. Regarding these three critical points, we believe we have found an alternative solution. This study aims to present a practical, efficient, yet innovative automated solution of volume calculation with high precision, always by using an algorithm in AutoCAD scripting. I'm going to explain step by step the process we have followed. Firstly, all the gathered data from the total station will be tabulated in an Excel spreadsheet. And then, since Python is a high-level programming language and it offers a variety of libraries, one of which will allow us to upload the Excel file with all this data and record all that is needed to continue the code. This algorithm aims to prepare then a notepad file with AutoCAD command lines. And lastly, a file will be imported and executed in the AutoCAD software. AutoCAD allows us to do this thing. Okay. The algorithm uses the environment of AutoCAD software to compute the volume and the surface of terrain. It utilizes a superspline method for interpolation of the 3D data points gathered from the land measurements. The output of this method are the AutoCAD drawings, including the 3D surface in here and the 3D volume later. So AutoCAD especially is capable of executing automatically multiple command lines according to its scripting language. For example, we have a basic example of building 2 different lines in AutoCAD simply by using this scripting language as shown below here. We have 2 lines with separate coordinates, and then we drag and drop the file in the AutoCAD working space, and it will show, as you may see, 2 lines formed. The data tabulated in Excel spreadsheet is analyzed and checked for possible errors using Python 3, the version 3.7. So data will in the AutoCAD working space there will be formed lines and splines, and then construct for each of them small surfaces to be all united at last for one united surface. Data points are prepared accordingly to be recognized by the AutoCAD scripting. So the 3D surface will serve as the last step to draw our volume. As you may see, the lowest and the highest z coordinates of the surface will be considered as boundaries for the volume calculation. And by using the slice command, we will have cut and fill volumes. As in this case, we have the cut and fill volume. Then we have a user interface window, which is also prepared in Python. And we will import the Excel file we have in our computer with the data from the total station. Also, it is important to enter the number of horizontal grid lines. After completing these 2, we have now ready the algorithm. Only we have to run it. So the application will automatically generate a file saved as .pstr. This is an index in order to save the notepad file into an AutoCAD scripting file, so that AutoCAD can recognize it. It requires simply a drag and drop. And of course, it will save several hours of office work. So this method was initially applied in classroom, later used in surveying field studies. The results suggest that this approach can improve the process of surface and volume computation. Of course, there are also needed further improvements and future research, especially for generating contour maps. So advantages of implementing this method, I can mention they are fast, accurate, user-friendly, cost-efficient. Instead of doing the same design repetitively, civil engineers must start to use these scripting files because it will ease their work, and as I mentioned before, it is less time consuming. So thank you everyone for listening to my presentation. If I may, I can also I can also represent to you a way of how this works. May I?
Of course. If it is short.
Okay. Can you see my screen?
Yeah.
So as I mentioned, we run the Python. We import the Excel file, which is in our computer.
Adela, one moment, please. We cannot see your screen. Can you try to share it again?
Okay.
Yes, now it's being shared.
Okay, let me rerun. So again, we run the Python code. We import our Excel file, which we have, with the data from measured from the total station. We enter the number of horizontal grid lines. We run analysis, and now it is ready, I believe. Process is finished. Automatically, it creates this scripting file, which we drag and drop in AutoCAD's working space, and we now have the surface. As you may see, it is all done automatically, not by doing manually as it is known in our field. So thank you. If you have any questions, I'm open to answer them.
Thank you, Daniela, for this interesting presentation and interesting topic. If the audience has any more questions. If not, then we can continue. Thank you, Daniela. We can continue to the last two presentations. One will be done by me, which is polypropylene reinforced mortar coating for improvement of unreinforced masonry shear capacity. And the other one will be held by Dr. Luga after my presentation. I think that. So this is a study that has been done in the framework of PhD thesis some years ago, but since that it can be actual after the earthquake that happened in Albania last year, I find it of interest to discuss in this conference. Regarding the overview, there will be an introduction, material and method, the experimental campaign, the modeling, results and conclusion. The first question that may arise by us is why do unreinforced masonry buildings fail? So why they cannot stand the earthquake load? Firstly, it is due to the insufficient lateral resistance capacity. Secondly, it can be because of material degradation over time. As you know, that this technique is quite old and materials can deteriorate over time. They are often designed using old standards or not designed at all. So they are just built by the master's knowledge, especially some 50 or 100 years ago. Then during an earthquake, we have lateral seismic forces that can induce out-of-plane or in-plane loading. And the failure can occur in some of the most common ways, like shear failure, sliding failure, rocking failure, or toe crushing failure. Especially also inside the brick, it can crack during a vertical crack if the brick and the mortar do not have sufficient strength. It can crack during compressive cracking in figure B, or it can occur during joint tensile cracking along the mortar joint or diagonal, which is also a very dangerous failure, as well as diagonal tensile cracking in a step-like diagonal in the vertical plane of the wall. So this, if we can limit out-of-plane failure by adding various strengthening techniques like tying or by using external additional steel rings or any other element, Regarding the in-plane loading, there is nothing that we can add externally, but we need to strengthen the overall properties of the masonry. For this reason, we need to find some ways that can improve this capacity in in-plane loadings. The experimental campaign that we did was conducting a set of diagonal compression tests as of ASTM 519, which is the American standard for testing of diagonal compression. We should understand that this technique can, let's say, imitate what an earthquake can cause to the wall, but using static loading. We use three-plane or unreinforced masonry walls made of 1.2 by 1.2 meter and 0.25 meter thickness. And we also use the three unreinforced masonry, then reinforced with polypropylene mortar coating. The diagonal compression test is done as in the figure to the right, where we have a hydraulic jack that is exerting the pressure. We have the loading shoe on both edges of the main diagonal where it is compressed, and we have dial gauges that measure deformation on both sides of the wall. The wall has been constructed using two-leaf English bond, using clay bricks, and the mortar joint is 15 millimeter thick. These walls have been built by an experienced mason so that we can somehow have a similar construction typology for unreinforced masonry buildings that are in Albania or elsewhere. The volumetric mix ratio of cement, lime, and sand is 1:6. Then these walls were cracked, let's say, were tested in diagonal compression, or they were reinforced, the group of three. And the main outcome of the experimental result was the type of failure mode for all the panels. Then we identified the main crack pattern, we identified the shear stress and strain diagram, we could measure the maximum shear stress and the ultimate drift. Nevertheless, before we made the diagonal compression test, we had to identify the brick and the mortar's individual mechanical parameters. That's why we did tests on these individual samples, and we found out that the brick compressive strength was 24.03 megapascal, the average one, and the flexural strength around 4.53. Whereas for the mortar, we had a 5.32 megapascal compressive strength and almost 1 megapascal tensile strength. However, we already know that in modeling or when we made the analysis for mortars, we assume that the masonry as a whole does not possess any tensile strength. The formulas that are used to calculate all these parameters that we talked are the ones described in the ASTM 519. And the schematic view of the diagonal compression test, as we saw in this slide, is seen here. So it is very important that we have a good connection between the loading shoe and between the hydraulic jack so that the whole load is distributed evenly and properly through these steel rods that are connecting the wall. Before doing the diagonal compression test, also the strengthening technique of polypropylene fibers that are embedded in this inorganic mortar coating is shown in the figure here. So basically, these are the polypropylene fibers, which are pretty thin, and we have cut them into 12 millimeter length. They are inserted in the mortar mix. They are dry mixed together with sand and cement. And then afterwards, the mortar is prepared and applied. One layer is applied firstly in order to improve rotation. And then we are adding the second layer. So the overall strengthening plastering layer is about 25 millimeter thickness. The composition of mortar is a mix of just cement and sand. We started with a ratio of 1:1. We have also done some other tests in a ratio of 1:4, so 1 portion of cement and 4 portions of sand. And the polypropylene fiber amount is around 2% in volume. Then I would like to show you one short video of the diagonal compression test on a wall, of course with a speeded up video. You will see the development of the cracks just right after failure. So as you can see, now it starts to be seen, a diagonal crack along the compressed diagonal until the load will, until the wall will fail completely and will not carry any more load. As you can see now, the diagonal is more visible, and it's not only along the main diagonal, but it spreads also parallel to that one. If we had, if the mortar would have been a little weaker, then we could also see a type of sliding failure in the masonry wall. So this is one of the worst types of failure for an unreinforced masonry wall, and if we would like to limit it, so this is a picture of all the failure modes for the tested samples. In the first and second figure, it's both sides of the same wall that you can see the diagonal crack. In wall number 1, we could also see a part of it in a sliding failure. And then the other 2 walls again have failed in almost a similar way. Whereas for the polypropylene reinforced panels, we could clearly see a distinct diagonal crack, a thick diagonal crack along the reinforced layer. If we would compare the mechanical parameters, the maximum load that the plane and the polypropylene could carry. So there is a clear difference of 2.3 times. So polypropylene reinforced panel could carry 2.32 times more load, as well as the shear strength. If you see for the unreinforced panel is 0.3 megapascal, and for reinforced one is 0.8. Regarding ductility, this is an interesting topic and interesting case that because we added a very stiff mortar and a ratio of 1:1, the wall didn't have large ductility, let's say. So it had less than unreinforced panel. However, if you could, if we compare the shear strength, it is considerably high. For this reason, in the future test, we had to change the mixture and the composition not to be 1:1, but 1:4. We also did a finite element modeling using Diana software, using simplified modeling method with brick crack interface, where we had to model bricks and brick joint and brick crack interfaces using some elements that already the program possesses. So we had these elements, Q8 MEM and CL12I interface element. This is how we modeled the panel. So we had to consider the brick, the joint, and the cracked interface, as well as we ran the analysis. And we somehow tried to simulate what actually happened in the test results. And you could see here the distribution of the stresses along the compressed diagonal. We also tried to calculate the stress strain, shear stress and shear strain for both cases, for the experimental result and for the numerical result. As you can see, it is a pretty good fit, but with the numerical results being a little bit more ductile than the actual ones. So To conclude, we did 6 diagonal compression tests, 3 on plane and 3 on polypropylene reinforced panels. The main aim was to observe the structural behavior of masonry and investigate the performance of reinforced panel. Polypropylene reinforced mortar plastering technique showed on average an improvement of ultimate strength and the modulus of rigidity. However, it demonstrated a less ductile behavior with a deformation capacity of 70% of what the unreinforced panel had. And also the model that we developed showed a pretty good correlation with the experimental result, which we believe that polypropylene reinforced mortar coating can be used, can be a good technique to strengthen the wall, provided that we do not need to have, let's say, an increased ductility of the unreinforced masonry. Thank you. If you have any question, I'd be glad to answer you. Anyway, if not, then we can continue with the other presentation of my colleague, Professor Luga. That can be from here.
Okay, thank you, everyone. We have come almost to the end of this conference. It was an interesting conference with several different topics and with very interesting ones. This is the last presentation, and I'll try to keep it short because it has been a long time for all of us. So the topic is called the effect of Ekbasan ground granulated blast furnace slag addition on different properties of cement mortars. Somehow this is similar to the topic that Ilda presented in the beginning. So you know, slag is known as a non-metallic waste material disposed from the iron and steel production. The first usage of slag starts back in the early 20th century when the modern processes of iron and steel production began to be developed. The need to use an industrial byproduct, all industrial byproducts, was strong, and storage space was missing, which is even today in several countries is an actual problem. Iron ores consist of compounds of iron, usually iron oxides such as hematite, magnetite, limonite, and siderite. And there are also some impurities such as silica and clay. So the main composition of blast furnace slag, which is a byproduct of steel production industry, as you can see from the scheme in the right, it is shown the furnace, the blast furnace, where the iron ore is molten to produce the pure iron, and later steel and other types of compositions of iron. So in the blast furnace, it is put the iron ore together with lime and coke. So coke is used to produce high heat in order to melt the iron, whereas limestone is used to connect or to bind the impurities which come from the iron ore, as well as the oxides, which will be released from the chemical and physical processes during this high burning process. And as you can see here, as iron is heavier, it comes down here to the lower part, whereas slag is lighter. It stands in the upper part of this molten mass, and it is obtained from the from the right side, from the upper part. So these slags are the byproducts. So we do not produce slag purposely, but it comes out from the as a waste material from the production of iron. The main composition of blast furnace slag is mainly silica, alumina, and lime. Slag also contains small percentages of iron oxide, magnesia, mangan, and sulfur. The rate of cooling method of liquid blast furnace slag results in the production of three types of slag in solid form: air-cooled, expanded, and granulated blast furnace slag. So normally there are different methods of disposing the slag. One of them is air-cooled slag, which is just, we dispose the slag in the outer environment. In this case, the slag cools slowly, so in this way it produces a very hard rock, similar to the igneous rocks. So it's very hard and strong. So it has a crystalline structure. As it cools slowly. The expanded slag, it is generally used as a lightweight aggregate in the production of lightweight concrete. And the third one is the granulated blast furnace slag, which is produced by the fast cooling of the slag, of the blast furnace slag. In this case, as the cooling process is faster, the slag will not have time to form a crystalline structure, but in this case, we will have an amorphous structure of the slag. And this type of slag is the one which is, when finely ground into a powder form, it can be used as an additional material or as an admixture to the cement during the production of cement or in the production of concrete, etc. But for sure, it should have certain qualities, which some of them we have tried to investigate in this research. So during the communist period, Albania was developed as an intensive mining country consisting of a large number of mines and processing units of metals. The foundations of steel production industry in Albania are settled since 1975. The slag, as a byproduct of the process of the production of steel, is in high amounts deposited in special fields in Elbasan, where the production of steel is concentrated. In the figure on the right, you can see the steel factory in Elbasan, which nowadays it's not fully working. So nowadays, the steel factory of Elbasan produces an average of 600 tons of steel per year. There are large amounts of slag dislocated in special areas. In the figures below, you can see some of the disposed slag inside this steel factory. The only usage of ground granulated blast furnace slag of Elbasan is in the road construction, where it is proven to be a good stabilizing material. In its positive year, it is used about 180 tons of slag in road construction, so it's not enough. So slag is still underused in Albania. The slag is underused in Albanian construction industry, and even though it is not a danger for the environment and it's not harmful, the large stock of ground granulated blast furnace slag is creating different problems to the region. The purpose of this research is to study the effect of local ground granulated blast furnace slag as a partially pressing material in Portland cement mortars. So in here, there are two tables. The first one shows shows 6 different series of mortar mixes that are used during the investigation. There is an incremental increase of the amount of addition of slag in the cement. So starting from 0 in the first one, which is the control specimen, 55%, 10%, 15%, 20, up to 25% replacement. So in this study, different aspects of the use of ground granulated blast furnace slag as a Portland cement replacing material were investigated through laboratory experiments, consisting in evaluating its effect on the normal consistency, initial and final setting time, as well as flexure and compressive strength. So before knowing other properties of a certain binding material, in the beginning we should know its basic behavior on the fresh and hardened mortars or on concrete. So this is the first study related to the investigation of the properties of local ground granulated blast furnace slag, which started with these three properties of fresh mortars, such as normal consistency in initial and final setting time, as well as two important properties of the hardened mortars or concrete, such as flexural and compressive strength. Also in the table below, there is the chemical composition of the blast furnace slag. Regarding the normal consistency, the test was performed in accordance with EN 196.3, and the same procedure was done for all the 6 series. As we can see in the figure in the left, the water content decreases as the slag amount increases. So it's the water content for the normal consistency is about 0.34 in the beginning, and with the use of 25% of slag, it reaches to 0.3, which means that it decreases the requirement of water by adding slag. Actually, it's a good thing, but this is not general for the slag, because generally slag is finer than cement and requires more water than cement alone. So in this case, this local slag has some different properties. Maybe the grinding is not so fine as in general. In the right, we can see the initial and setting time results. For the initial setting time, there is an irregular, so there is not a certain trend or a linear trend, whereas for the final setting time, we can see that there is a linear trend, almost linear trend, that shows that by increasing the slag amount, it increases also the final setting time. Whereas coming to the hardened properties, we perform the flexural strength and the compressive strength of the mortars. The flexural strength was performed on 40 times 40 times 160 millimeter dimensions of mortar beams. In the left, we see the results of the 7 and 28 days flexural strength, which also shows an irregular trend. Actually, this is general for the flexural strength, as it is in mortars. It has a brittle failure, which doesn't allow to get exact results. Whereas coming to the compressive strength, the trend is decreasing as the compressive strength, as the amount of slag increases. Now we have to analyze this part. Why there is such a decrease while increasing the amount of slag? And from the results and from the chemical composition, we can see that there is a very high amount of iron oxide in the content of the slag, in the composition of slag. So in order to analyze the results, it must be taken into consideration the chemical composition of the slag, which resulted with a high percentage of iron oxide. The high content of iron oxide decreases the percentage of calcium oxide and silicon oxide, which are very important for the binding and pozzolanic properties of these mineral admixtures. This results in a decrease in the cementitious and pozzolanic properties of the slag. So, to come to the conclusions of this investigation, based on the investigation, it was concluded that this ground-granulated blast furnace slag deposited in the metallurgical factory of Elbasan, Albania, is not very appropriate for its use as a mineral admixture because of its high amount of iron oxide in its composition. This also shows that the high amount of iron oxide the high amount of iron was lost during the production of steel. So this oxide should be in the other part of the production, not as the waste. So by a better treatment of the raw materials, higher amounts of pure iron or steel could be produced. At the same time, the generated slag would have better properties and be more usable. So this was our investigation and our conclusions. We would be glad to have your questions. So if there are no questions, we have come up to the end of this conference. It was very interesting. There were very interesting presentations. I want to thank all the participants, with also the attendees that participated by listening to these presentations and with their questions also. I hope also you enjoyed your participation and listening to the presentations. And I hope through this conference we could build new collaborations and also new research projects with all of us together. So I would like also to invite the organizing committee members to make some comments. Also, everyone is free to make your comments and to your impressions about this this two-day conference. Okay, thank you, everyone.
The abstract book and proceedings.
We are going to upload the abstract book and the book of proceedings in the webpage of the conference, so you will be able, and we'll share with you via email as soon as it will be published, and you will be able to download the abstract and proceeding books from the website of the conference. Thank you very much. See you in future activities. Bye.
Hello. Thank you. It was a pleasure.
Thank you.
Bye-bye.